Friends, this lecture we are going to talk about electric and hybrid vehicles. The next topic will be very interesting, which is on electric vehicles. What happens to all the mechanical parts? Here, the combustion, compression, whatever we were talking about is completely converted. You have a battery, from a battery we try to drive or we try to derive energy such that the other things can happen. So, electric vehicle is the new entry into the market which is there for the last 10 years. So, here we are going to use only battery for the energy. No petrol, no diesel is used. And from battery what do we do is we try to run motors. And from this motor we are trying to take it to the transmission system whatever we want, and finally we try to connect it with the wheels. What earlier used to happen is you had an engine, in the engine you used to pour petrol or diesel, and then there used to be a mechanical system which tries to do all those things, and there used to be, after the combustion, there used to exhaust. They used to throw out the combust gas, which can be rich in fuel, which can be lean in fuel, and which created lot of pollution. So, now that system itself is gone. It just operates by a battery. Of course, the battery whatever we use here has to have very high torque. Very high torque means very high current. Very high current means the number of batteries have to be more. And here the battery will be charged frequently. So, the life of the battery is always a challenge. So, nowadays when you buy any scooter, they used to say the battery is given a warranty for 3 years. So, that means to say you can try to do. Friends, it is not the 3-year matters. They try to fix a specification for 1000 times you are allowed to charge. You are allowed to charge the battery. Moment this 1000 hits faster or slower, the battery has to be changed. So, the battery plays a very important role in EV vehicle. Rest all is not a big deal, but this battery is a bigger deal. An electric vehicle is a vehicle that uses one or more electric motors for propulsion. So, what is the advantage? The electric motors means you can very fast control. It's like your fan switching off and switching on. It's a motor. You switch off, you switch on. And if you want to switch on and then off, you can rotate in one direction. When you try to reverse it, immediately it stops. So, motor can be easily controlled, and there are lot of controllers which are available for motor, which can do lot of wonderful things. They can have a sinusoidal control, they can have a sawtooth control, lot of things can be done. So, motor is going to be attached to the transmission system. Their engine output will be attached to the transmission system. The electric motors are the replacement for IC engines. The main components of an electric vehicle are battery, which will be charged. Battery is like your UPS battery, your cell phone battery, your laptop battery, it is almost the same. And then you have an inverter. Why do you have an inverter? You convert DC into AC or whatever it is. So, you have an inverter. So, generally in the inverter we lose lot of efficiency. Now, we are trying to improve the efficiency of the inverter and the controller. So, inverter is again controlled by a controller, motor is controlled by a controller, transmission system yes, and vehicle yes. So, here you can also go without gears. So, working of an electric vehicle, the power is converted from a DC battery to an AC for the electric motor. DC motors are there, but DC motors are not so very efficient. So, AC motors are little lighter in weight and it can be better controlled. So, people get attached to an AC motor. So, from an AC motor it gets attached to a transmission system. So, the power is converted from a DC battery to an AC of the electric motor. When the accelerator pedal is pressed, it sends a signal to the controller which adjusts the vehicle speed by changing the frequency of the AC power from the inverter to the motor. So, when we press the accelerator, okay friends, we missed out a point in the previous discussion. When we press the accelerator, this accelerator tries to, in SI engine, tries to improve the air mixing ratio. When you do the same in CI engine, when you keep pressing the accelerator, the metered quantity of fuel which enters into the system is also changed. Here what happens in electric vehicle, the accelerator pedal is, when it is pressed, it sends a signal to the controller. Where is the controller? It is here, right? The controller which adjusts the vehicle speed by changing the frequency of the AC power from the inverter to the motor. Okay. The motor connects and turns the wheel through a transmission system. When the brakes are pressed, the motor becomes an alternator and produces power which is sent back to the battery. So, this is called as regenerative braking system. So, you remember in the power plant we saw regenerative cycles. So, in the same way in automobile also you have, when the brakes are pressed, accelerator brake, when the brakes are pressed, the motor becomes an alternator and produces power. This power is sent back to the battery. So, DC controller, batteries, and then you have a DC motor. When the brakes are pressed, the motor becomes an alternative and produces power which is given back to the battery. The advantages and disadvantages of EV vehicle. So, it is better for the environment, no combustion is thrown, electricity is less expensive than the fuel, lesser maintenance cost because it is completely electric, and though there are parts, but these parts to a large extent are improved and the maintenance cost goes high, the noise is very low. The EV, the only biggest challenge up till now is it can travel from 100 kilometers to 400 kilometers, it has to be recharged. The charging takes long time, but nowadays you have fast chargers which are come into action. The initial investment is high. When we try to buy a four-wheeler, yes it is. Two-wheeler, it is almost comparable. The charging stations are not available anywhere. The network, the supply chain management of the electric charging stations are getting improved in this country. So, there are different types, because since you know the battery is the heart. So, now we have to see what are the different types of batteries which are available for us. There are batteries used in laptop, there are batteries used in smartphones, there are batteries used in your wall clock, there are batteries used in cars also. So, all of them are not the same, there are different batteries. So, predominantly what batteries are used in EV vehicles are lithium ion batteries. Lithium is not a freely available material. So, this dictates the cost of the battery. The lithium, so battery has two major challenges. One is the cost, the other one is the lifetime. People are working on the third one is their size, is their shape and size. Because majority of the batteries which are available are cuboidal in nature. And if we could make this cuboidal into a curvature one, flexible, so then it tries to reduce the space. So, people are working on all the three. Lithium ion batteries are most commonly used in electric light motor vehicles because of their high power to weight ratio, good high temperature performance, excellent specific energy and low self discharge rate. Okay. So, the lithium ions battery is, this is the schematic diagram. You will have a current collector on one side, current collector on the other side. You will have electrolyte which is there. So, the lithium ions, this is anode and cathode. The lithium ions move from here to here through, and then they are separated by a separator. These are electrolyte which is in between. Right? The electrolytes can be solid electrolyte, it can be liquid electrolyte. Today we are talking about solid electrolytes. Lithium ion batteries are better than the other batteries at maintaining the ability of holding the full charge over a period of time. These batteries are recyclable and it is good option regarding to the environmental aspects. They have long cycle life, even they support higher energy costs, exceptional power efficiency, longer shelf life and eco-friendliness are the basic advantage of going for lithium ion batteries. You have lead acid batteries which are being the conventional batteries. So, here you have an electrolyte which is there, which is liquid electrolyte, and this has been in the market for a long time. If you go back to this figure, you saw an alternator. This alternator is attached to a battery, I said. So, this battery which is used commonly now in market is the lead acid batteries. The lead acid batteries technology is still in the development stage. These batteries are comparatively wide operating temperature range and have low energy density. This has high. Lithium ion batteries have high, this has low. They are easier to recycle. 95% of the content of the battery can be reused when which is better for the environment. Lead acid batteries. But lead is toxic. The lead acid batteries have a relatively low depth of discharge. So, it directly impacts their cycle life. These batteries tend to be expensive because they don't last as long as they often need to be, replaces within 4 to 15 years depending upon the type. Lead acid batteries are the second type. The third one is nickel metal hydride batteries. These batteries have one pole has nickel alloy, whereas the other pole has nickel oxygen hydroxide with the electrolyte of potassium hydroxide. So, nickel metal hydride batteries are there. So, you have nickel at one end and the other pole is nickel oxy hydroxide with the electrolyte of KOH. Right. It is usually slower to charge and discharge this battery. So, charging is also very slow, discharging is also very slow. It contains less power per weight. So, the power densities are low. So, it takes a longer time for charging of these batteries. These batteries are operate at wide temperatures, but whereas lithium ion batteries does not operate at wider temperature zones. The second and third operates at a wider range, but in extreme heat, nickel metal hydride batteries can discharge faster. So, typically the lifetime is 3000 cycles. These batteries are widely used in automobile, computer, medical equipments and henceforth. Okay. So, these are the different types of batteries which are now thought of. Lithium ion is most exhaustively used. It is expensive, but it is exhaustively used. We have lead acid batteries. We also have nickel metal hydride batteries. Charger, they are called as onboard charger. There are two types of charging stations today, AC charging station and DC charging station. The batteries can only be charged in DC electric power, while most electricity is delivered from the power grid as AC. So, for this reason, the electric vehicles have built-in AC to DC converter, commonly known as onboard charger. What comes through transmission? Generally, what happens, friends, you have three boxes in the electricity. So, one is generation, where we saw it can be through hydro, thermal, nuclear, it can be geo, it can be solar. So, all these things are generation. Next is transmission. I have to transmit from the generation station across the country, that is transmission. The third one is the distribution, which comes from the transmission. For example, to your city it will come here, your house will be here. So, from here to here it is distribution. So, the power, the transformer will step down or step up and then transmit to your house, right, through a wire. So, generally what comes in the entire cycle is AC. In solar, what happens? They are trying to make standalone systems. So, the solar will be Solar will be standalone, so directly you get a DC, so you don't put this onboard charger. Moment you put a converter, the efficiency is lost or the power is lost. At the AC charging station, AC power from a grid is supplied to its onboard charge while producing DC power to produce the battery. So there are three types of chargers which are there. One is rapid charger, slow charger and fast charger. Rapid charger are very high currents are passed, right? Fast charger is slightly lower, and then the slow charger are used in nickel metal hydrides. So single speed transmission is there, multiple speed transmission is there. So it is the most common type, single speed transmission, consisting of a fixed gear ratio. So single speed, so from a motor you have a fixed gear ratio. So then it is called as a single speed. It simplifies the drivetrain, reduces weight and complexity, and still delivers instant torque for acceleration. So this include Tesla Model S and Chevrolet Bolt. So they use a single speed transmission. Multi-speed transmission is some high performance EV vehicles like Porsche Taycan and then Audi e-tron GT uses two-speed or multi-speed transmission to improve acceleration. One speed means motor is given. After motor you have a gearbox. So this gearbox tries to give you the torque, right? The speed and torque are adjusted by this, right? Uses a two-speed multi-speed transmission to improve the acceleration, top speed and overall efficiency by keeping the motor operating in an optimum power range. Multi-speed transmission is also there, single is also there. Rectifiers, these are rectifiers which you would have studied in your electrical course, basic electrical, half-wave rectifier and full-wave rectifier. Rectifier is an electronic device that converts an alternative current into a direct current by using a PN junction, one or more PN junctions, which converts an AC into a DC, because motor can operate in, the battery is DC, right? So what comes to your home is AC, then DC. The diode behaves as one-way valve that allows control of flow in a single direction. This process is called as rectification. The rectifier are used in AC-DC converter, a conversion stage of plugs in EVs, where the grid electricity is first met with a device. Then power converter. The power converter are classified according to the input-output type of power, DC-DC converter, AC-AC, cyclotron converter. So there are two things. So DC-DC converter, AC-AC cyclotron converter. DC-DC converters are designed to increase or decrease the input voltage to the desired output. Therefore, a device known as buck converter or a step-down converter decreases the output value according to the input voltage, while booster converter or step-up converter generates the increased output voltage. So booster converter, buck converter, two things are there. Friends, these are just for information and for you to know, because mechanical you understand many things, but in electric side what happens you should understand. So what we saw till now was battery, then we saw onboard charger, then we saw speed mechanisms, and now then rectifier. Finally is the power converter. The cyclotron converter are used to convert high input power at one frequency to output of different frequencies is the boost cyclotron converter. Okay. DC-DC converter, increase decrease input voltage. AC-AC converter, cyclotron, which is one frequency to multiple frequencies. So this is nothing but a variable frequency drive, VFD. Variable frequency drive, variable because what comes in AC is a single frequency, 50 Hertz. Now the cyclotron will convert into variable frequency. Variable frequency you can try to convert the RPM or the torque accordingly. So that's what is the advantage, which can be achieved by an inverter. Controller, which is the heart of the EV vehicle, and today sensors, onboard sensors, there are a lot of things which are getting incorporated in SI engine as well as CI engine. So controller, they require control signals are generated by microcontroller and commutate power electronic devices with switches to provide the required speed and torque. This is done by this. inverter. EV inverters are used for AC DC conversion. They are used to provide the required AC voltage and current for AC motors from a DC battery power supply. So, that is why inverters come into existence. So, the controller is very important, and sensors are multiple sensors. You have pressure sensor, air fuel, the pressure sensors, torque sensors. There are so many sensors which are there. So, number of moving parts in an electric vehicle is reduced. So, you can see here the traction battery bank is here. Then you have a charging point which gets attached to the external world. So, you have an onboard charger, auxiliary battery, then it is battery converter, then motor drives here, electric motor which is here, then transmission systems. So, transmission systems is what we saw here. You will get a variable frequency drive. So, the last part is a mixture of these two, because initially when the electric vehicle came, people were not ready to accept electric vehicle, and people also felt that the battery is very difficult for a long drive. So, then people decided, let us have a mixture of both, wherein which you will have a normal vehicle where the starting will be done by petrol or diesel. After a threshold value, it switches to electric. So, the initial start will be done by it, and the battery gets charged, and then you get into the electric. So, electric can be used for control, and then you can have a pollution reduction. A hybrid energy vehicle is a type of vehicle that combines a conventional internal combustion engine with the electric power propulsion system. So, this is a typical hybrid engine. So, you can hybrid vehicle, you can see here the battery, inverter, motor, transmission system. Then you have a driving shaft, differential, both wheels are given control, right. So, now the other thing what we will see is engine, right, engine which is attached to the transmission system, engine which is attached to the transmission system, then drive shafts, differential, wheels. But here there is a difference. So, where is the difference? It has a difference here. So, the engine, what it does is it sends its power to a power split. So, from the power split, it gets divided into two parts. One part gets into the transmission drive shaft and goes away. The other part, it gets into the generator. Why generator? This generator is in turn going to generate power, and it is going to give it to the inverter. From the inverter, it gets into the motor. So, here the power is split into two parts. Initially, when you try to give the starting torque is very high, it goes from the engine. When it goes from the engine, the generator inverter is also getting power. It gets generator, and that is giving to an inverter. Inverter, it goes to a motor. After a certain speed, this fellow is removed and this gets into action. It is happening automatically by a controller. So, the hybrid modern vehicles, HEVs, may use the efficiency improving technologies such as regenerative brakes, which convert the vehicle kinetic energy to electric energy, which is stored in the battery or a supercapacitor. So, we saw the regenerative, how does it happen when you apply brake, how is it getting stored as the energy. So, the advantage is going to be cleaner emission, less fuel dependency, small and efficient engines are going to be there in hybrid. In the last decade, lot of hybrid vehicles have come into action. The disadvantages is sometimes it gives a low performance. These vehicles are expensive because you use both the combinations, and it has a higher maintenance cost because engine is also their mechanical part, and then you will have a battery which is also there. So, there is a drive train. So, the drive train or the parallel refers to a set of components that generate the power required to move the vehicle and deliver it to the wheels. So, this is serial style, this is parallel style, and this is a blend of serial and parallel style. Serial style is you have an engine, there is a generator, inverter is attached. So, it is in serial. So, this goes inverter, and then from the battery also it comes to the inverter, then it goes to a motor transmission system. When you take it parallel, what happens is you have battery which is given, motor, and that goes to the transmission system. The engine also gives it to the transmission system. So, serial and parallel is half of them is serial and half is parallel. So, you have a power splitter device. So, based on the hybrid electric vehicle, the drivetrains can be categorized as serial type, parallel type, mild hybrid type, or plug-in hybrid type. So, plug-in hybrid type and mild hybrid vehicle, these two are almost falling in the serial type. So, plug-in and mild, you can see here. Plug-in hybrid is you have the energy storage system. So, if you go back and look into this, this is the traction of battery banks. So, that is what is told here, the energy storage system. So, from there you will have a power electronic converter which goes to a motor, and the mechanical coupling happens here. This is plug-in hybrid, you charge the battery and then use it. The other one is mild hybrid vehicle, is you will have engine which everything is there, and then you have a small support which is given by the battery type. So, you will have 36 volt battery, 12 volt battery. So, this 36 volt also is sent to the DC-DC converter, 12 is also given here. This is engine control unit, and you have the inverter which is placed. So, these are the 4 types. So, finally, when we try to compare the IC engine versus electric, pure electric versus hybrid, you will see 3 parts, right. So, the power fuel source in electric vehicle, it is from the battery pack, which is DC battery pack. The hybrid will have electricity plus fossil fuel will be used here. In IC, it will be only fossil fuel used here. The engine will have electric motor. So, here hybrid will have internal combustion engine and electric motor will be there. When we talk about IC, it will be internal combustion engine only. Then the fuel efficiency will depend on the battery range. So, it is a combined, so it depends on IC as well as battery. Then IC will be, IC combustion engine will be only the fuel whatever is there. The emission levels are low compared to IC, it is very low, and hybrid vehicle, it is the lowest. So, the next one, since some amount of IC is involved, it is slightly higher as compared to electric vehicles. Here it is the fuel efficiency level is very high because it is only combustion based. The range electric vehicle are high. This is similar to the conventional vehicles, and this is comparatively lesser. Out of these 3, it is lesser. But today the electric vehicles are also coming in comparison with IC engines. The charging, it is required. Here in hybrid and here it is not required, because whatever charging happens will happen by the first part of the IC. When it is running, it will try to charge the battery, from there it is going to use. So, here it is not required. Friends, so I think this lecture would have given you lot of insight about IC engine, 2-stroke engine, 4-stroke engine, hybrid engine and electric engines. So, you will be able to appreciate how does all these things happen from the science of thermodynamics. There are few exercises which I wanted you to try. If you have a bike, right, if you have a bike or a scooter, then or a TVS 50 or a moped, what I would like you to do is, you try to pour 1 liter of petrol or whatever is the fuel, you pour it inside, and then what you do, as a single operator, you try to drive it to the fullest extent. Then you try to repeat the same experiment with 2 people. Try to see what is the difference in performance and the efficiency of the engine. So, then try to browse through in net and try to figure out if 2 people sit in a car or 4 people sit in a car, how is the efficiency going to change? The next question is, if I am going to drive a car at low speed, high torque, what will be the mileage? High speed, low torque, what will be the mileage? If I try to load or switch on an AC in the car and drive, look at the mileage. Without an AC, look at the mileage. And sometimes when you start the scooter or car, you see here, gut, there will be a sound. So, where is this sound coming from? And when you start an EV vehicle, there is no sound. Why? The difference is coming. And when you try to look into an EV vehicle, you can go in the forward direction and reverse direction just by switching a small switch towards left and right. How does it happen? So, these are some of the things which I want you to browse or experience so that you can try to enjoy this lecture. To recap what we saw in this lecture, we saw what is IC engine, what is the difference between a steam power engine and an IC engine, that is external combustion and internal combustion, what is 4-stroke and what is 2-stroke, what is the difference between SI engine and CI engine, what are electric vehicles, and in electric vehicles, what are the elements of an electric vehicle we saw, what is the difference between EV vehicle and an IC engine vehicle, what are the various types of batteries, we saw 3 different types of batteries. Then we saw what are the different types of transmission drive system, parallel, serial, parallel, plug-in type and mild, all these things we saw. Then what do we understand from hybrid? And hybrid is in the initial phase, you try to run it on a fuel mode and then you switch to a battery, that is hybrid. And finally, we saw the comparison between IC, electric and hybrid engine. So, these are the references which we have used in making these slides, and thank you very much.